Good morning, everyone. It's a real honor for me to introduce you to the first talk of the day. His name is Dimitri Mikhalchuk, co-founder and chief revenue officer at TESLASUIT, who will present his talk, Connecting Human Body and Machine. Enjoy the video.
Hi, my name is Dimitri Mikhalchuk, and I'm a co-founder and a chief revenue officer at the TESLASUIT project. Today we'll be speaking about human-machine interfaces and a few products that we've introduced in order to make our life easier. In a fast-paced world, and nowadays people are looking for products and services that increase comfort, perform smoothly, and require ever more intuitive, natural interfaces. Technology is also increasingly in demand as a tool for expanding or even improving our own abilities and senses. More sophistication is needed in human-machine communication. We don't want to be restricted by having to carry complex devices, larger screens, and literally operate the three-dimensional environment using two-dimensional tools and interfaces. We need to reduce the gap between the human mental model and the way the computer, machine, or robot can accomplish a given task. Productivity growth in various industries with improved accuracy, safety, and speed of problem solving are also an important aspect. A never-ending need to improve the quality of life and well-being for people with disadvantages is a very strong driver for progress too. We are currently moving from the age of hands and touch, in which we operated buttons and knobs, to an age of mind and body in which we use our body as a user interface. Human-machine interfaces are shifting to being gateways to ever more natural forms of communication between humans and machines. Hence, we find ourselves in the journey further towards a full immersion, a world in which our reality is overlaid, mixed, and even extended with the digital sphere. For businesses, the path towards such a world is characterized by a myriad of opportunities. Amongst many others, closer, more engaging, more personal, and much more emotional customer interactions, better ways of visualizing and analyzing the information. However, we would not exist if it wasn't for challenges. A new mindset is required in order to shift from familiar, even less convenient interfaces to a new one. We know that despite the AI being widely used nowadays, and we're being promised that one day it will it will be able to outperform humans in every aspect, well, almost, a human control is still required during the learning process of the AI. We expect intelligent environments to be able to think, behave in ways that support humans. By providing personalized, adaptive, responsive, and proactive services in a variety of settings, such as our own personal living space, work, public places, and on the move. Humans are emotional and empathetic beings, expressing emotions not only in human-to-human communication, but also human-machine interactions. And as a result, an important challenge with regard to optimizing human technology, symbiosis, refers to how ICT captures and correlates emotional expressions, as well as how technology can express emotions and exhibit empathy in its behavior. The issue of symbiosis with humans with smart ecosystems is complex and multifaceted, extending beyond technical boundaries to a multidisciplinary approach, with the aim to also address ethical, societal, and philosophical compelling issues. As we can see from a couple of examples here, interfaces may introduce not only just a level of complexity for its acceptance and adoption, but also may carry a hefty price tag, time-consuming learning curve, and setup cost. Usability and ergonomics challenges as well. Wouldn't it be nice to have a simple, easy-to-use, plug-and-play interface that is also familiar to majority of potential users, which is also future-proof? Well, I believe we have an answer to this. Tesla Glove is an exoskeletal glove that we've introduced last year, which is capable of force feedback, positional and finger tracking, collecting biometrical data and about the user, and most importantly, it delivers physical interface capabilities inside a simulated environment. TESLASUIT is another good example of a two-way communication interface between the human body and a digital environment. It is designed in the form of a suit, yet it contains a number of technologies. It has a number of biometrical sensors, including EMG, PPG, EDA, bioimpedance, body temperature, EMS, TENS, and so on. With the EMS in TENS, it also doubles as a electro-haptic system, which outputs sensations sensations of touch, impact, from light to heavy, and so on. Motion capture system provides information on posture and position of a tracking human body. All these systems are capable of tracking the well-being of a user. Feed the AI with the data for adaptive machine response, measure body interactive performance, provide biofeedback, and is still wearable and soon to be a medical device. We leverage haptics to provide physical interface within the simulated world. Some of the real-world applications include various industries. A good example is Volvo, who we partnered just recently, and together we built a mixed reality case where we connect the car to the mixed reality. We provide the driver and passengers with the headset with the pass-through technology where they can see the real world and the augmentation layer overlaid over their eyes. The car is reacting to virtual objects that may appear on the road and reacts to various traffic situations that we can simulate inside the XR. TESLASUIT is an important interface here where it helps us reading how the users are behaving in different situations whilst the car is reacting to traffic collisions or near-miss situations and so on. Honda Robotics is another good example of our collaboration where Honda will be using our suits and gloves for training the robots for product testing, for example, actually training the robots to behave like humans. And in many ways, with the Tesla glove, we will enable the remote manipulation and telesensing as well. ESA is another good example where we partnered with Stardust Technologies on a project where we're building a simulation that can be taken on board of the spacecraft. The European Space Agency is a major sponsor of this project, and we're now going through a three-phase study on the human body and body reaction to microgravity, EMS and TENS in microgravity, and we're trying to assess the psychological state of the potential astronaut so we could provide full telemetry back to the control center. We could also mitigate difficult circumstances when somebody is traveling for a very prolonged period of time and yet needs some assistance. Where we work with enterprise market, Schlumberger and DTEC are good examples of proof of concepts that we've built together in safety training and critical situation assessment control. Where, as far as Schlumberger is concerned, we built what's called low frequency high impact event system, and this system helps us to train the speed of recovery from a stressful situation and regain operational control. Whereas DTEC was looking at ways to introduce full training, also walk the employees through a disaster so they could better understand how to do the maintenance and what consequences there may be should they make a mistake. All of these interfaces are very new, yet we're looking forward to its expansion, and hopefully the training will move to a digital domain where it will save us operational time, money, and will actually greatly expand what we can do within the training environment itself. This concludes my presentation. I hope you liked it, and I'm open to your questions.
I take the opportunity, Marco, to remember our audience that you can use the live chat and platform to submit questions to our guest speakers. Keep on, Marco.
Thank you. Hi, Dimitri. Can you hear us?
Hi, everyone.
Hi. It's a real pleasure to have you as the first digital guest. in this beautiful theater in the heart of Bologna. If you agree, I would like to start this Q&A session with a simple question.
With pleasure.
Your product seems to anticipate a scenario where haptic perception over the whole body could become a device for remote interaction. How do you evaluate this market growth, and how do you imagine making experience design accessible to as many designers as possible?
We see that the haptics is picking up the pace, and many companies, we're working in the B2B sector for now, but we see that many companies are now realizing how important the haptics is for any virtual environment. For one, it helps maintaining the focus of the brain within the virtual environment and keep it immersed. Because the moment we fall through the texture, for example, of the virtual world, the brain quickly disconnects from that reality and sees it as the augmentation instantly. So this is where we see that haptics is going to be only becoming more and more important in any type of interaction. Plus, on top of that, it helps saving a lot of time, because when we have the physical constraints inside the virtual reality, it helps us navigating much quicker and better, and it provides a more familiar interface, as in we are very tactile in our real world life. We like touching things. When we're babies, we learn through touch. So that's the basic instinct that we train throughout many years before we become visual, mostly. So and then the way we basically are looking at delivering our products and delivering the haptics to the rest of the world is we're building partnerships. We're building academic programs to help placing our products inside universities, inside the labs, so more and more people can get their hands on it and start thinking virtual with physical interaction, kind of thing.
Thank you.
Good morning, Dimitri. Andrea Cattabriga here speaking. Designer PhD fellow here at the advanced unit of the University of Bologna, here to link you with our audience. So we got one question for you, just a quite technical question about a possible application of your technology. And yeah, the question is, do you see a possible development where it could be possible to take advantage of the characteristics of your suite applied in high-risk working environments?
Of course. When we're looking at high-risk environments, the most important is that any user activity, when the person is leaving the virtual space and then is supposed to act in the real space, when we're talking about critical has to be taken with what's called subconscious decision-making. And the haptics, and in fact, the skin itself can talk both to conscious part of the brain, but also to the subconscious part of the brain directly. So it trains our almost like responses, which can be then triggered automatically when we don't even need to think about what we're doing. It's all going to be based on a reflex. So when we're talking about when we immerse ourselves into critical situations, and especially the more critical it becomes, the brain goes lower to basically our instincts. And if our new instincts are to be safe, to make ourselves safe in a specific situations, it only helps going through that without a mistake. So this is where haptics is ultra important. On top of that, our electrical stimulation haptics is even better because it touches directly the neural connectivity. So, and it works both with the spinal cord and the brain, physical part of the brain. So this is probably the fastest route to train a new skill for those environments.
Quite interesting. Got another question from Camilla Gironi asking, thank you for the great presentation. Is there any possibility to see an application of TESLASUIT's full body haptic fields as a tool for explainable artificial intelligence?
I would say so, because for starters, to train the artificial intelligence, for instance, to understand the human body, we need enough samples. And with TESLASUIT, the sampling itself becomes standardized because every sensor is on the same place on every human. We also provide physical motion, so secondary part to the data flow. So we need to understand whether the person is actually moving or not moving, for instance, to even understand why the level of activity, for instance, and biometrical sensors are outputting specific type of data. So that correlation is an important stream of information just to teach the AI. Then when we're talking about real application cases, for instance, Volvo itself, as well as Honda, have used our products to train what's called randomized human behavior patterns to the computer, because you know how once the algorithm is written for the computer, it will repeat it so perfectly that one can distinct that this is the machine that's doing the movement. Whereas in Volvo case, for example, it was all about product testing for humans, and therefore their robotic equipment was too perfect, and then the product would fail on with the human, you know, in the system. So they needed something to feed the computer that there's a level of randomity to show the delta of variation. So they just simply put the suit on, played multiple scenarios with multiple people, recorded it, passed it over to the machine to analyze, and that was it. Presto.
This looks like opening a room for expanding a Turing testing to physical externalization of AI. It's quite fascinating.
Indeed.
Thank you.
Thank you. If there are no further questions, we would like to thank you so much for your time and for your attending in our symposium. Thank you very much. It's been a pleasure. And now we'll leave the floor to Professor Michele Zannoni for the next speakers. Thank you.
Thank you.